IEEE-488 is a short-range digital communications 8-bit parallel multi-master interface bus specification. It was created in the late 1960s for use with automated test equipment and is still in use for that purpose. IEEE-488 was created as HPIB and is commonly called GPIB. It has been the subject of several standards. Origins: in the late 1960s, Hewlett-Packard was manufacturing various automated test and measurement instruments, such as digital multimeters and logic analyzers. They developed the HP interface bus to enable easier interconnection between instruments and controllers. The Army was relatively easy to implement using the technology at the time, using a simple parallel bus and several individual control lines. For example, the HP 59501 power supply programmer and HP 59306A relay actuator were both relatively simple HPIB peripherals implemented only in TTL, using no microprocessor. HP licensed the HPIB patents for a nominal fee to other manufacturers. It became known as the General Purpose Interface Bus, and became a de facto standard for automated and industrial instrument control. As GPIB became popular, it was formalized by various standards organizations. Standards: in 1975, the IEEE standardized the bus as Standard Digital Interface for Programmable Instrumentation, IEEE-488. It was revised in 1978. The standard was revised in 1987, and redesignated as IEEE-488.1. These standards formalize the mechanical, electrical, and basic protocol parameters of GPIB, but said nothing about the format of commands or data. In 1987, IEEE introduced standard codes, formats, protocols, and common commands, IEEE 488.2. It was revised in 1992. IEEE 488.2 provided for basic syntax and format conventions, as well as device-independent commands, data structures, error protocols, and the like. IEEE 488.2 built on IEEE 488.1 without superseding it. Equipment can conform to IEEE 488.1 without following IEEE 488.2. While IEEE 488.1 defined the hardware and IEEE 488.2 defined the protocol, there was still no standard for instrument-specific commands. Commands to control the same class of instrument, for example, multimeters, would vary between manufacturers and even models. The United States Air Force, and later Hewlett-Packard, recognized this problem. In 1989, HP developed their TML language, which was the forerunner to standard commands for programmable instrumentation. SCPI was introduced as an industry standard in 1990. SCPI added standard generic commands, and a series of instrument classes with corresponding class-specific commands. SCPI mandated the IEEE 488.2 syntax, but allowed other physical transports. The IEC developed their own standards in parallel with the IEEE, with IEC 60625-1 and IEC 60625-2, later replaced by IEC 60488. National Instruments introduced a backward-compatible extension to IEEE 488.1, originally known as HS488. It increased the maximum data rate to 8 MB/s, although the rate decreases as more devices are connected to the bus. This was incorporated into the standard in 2003, over HP's objections. In 2004, the IEEE and IEC combined their respective standards into a dual-logo IEEE-IEC standard IEC 60488-1, Standard for Higher Performance Protocol for the Standard Digital Interface for Programmable Instrumentation, Part 1, General, replaces IEEE 488.1/IEC 60625-1, and IEC 60488-2, Part 2, Codes, Formats, Protocols and Common Commands, replaces IEEE 488.2/IEC 60625-2. Characteristics: IEEE 488 is an 8-bit, electrically parallel bus. The bus employs 16 signal lines, (8 used for bidirectional data transfer, 3 for handshake, and 5 for bus management, plus 8 ground return lines. Every device on the bus has a unique 5-bit primary address, in the range from 0 to 30. The standard allows up to 15 devices to share a single physical bus of up to 20 meters total cable length. The physical topology can be linear or star. Active extenders allow longer buses, with up to 31 devices theoretically possible on a logical bus. Control and data transfer functions are logically separated. A controller can address one device as a and one or more devices as a wirelessness without having to participate in the data transfer. It is possible for multiple controllers to share the same bus. But only one can be the controller in charge at a time. In the original protocol, transfers use an interlocked, 3-wire valid accepted handshake. The maximum data rate is about 1 megabyte per second. The later HS488 extension relaxes the handshake requirements, allowing up to 8 MB/s. The slowest participating device determines the speed of the bus. Connectors: IEEE-488 specifies a 24-pin Amphenol-designed micro-ribbon connector. Micro-ribbon connectors have a D-shaped metal shell, but are larger than D-subminiature connectors. They are sometimes called Centronics connectors after the 36-pin micro-ribbon connector Centronics used for their printers. One unusual feature of IEEE-488 connectors is they commonly use a double-headed design, with male on one side, and female on the other. This allows stacking connectors for easy daisy chaining. Mechanical considerations limit the number of stacked connectors to 4 or fewer, although a possible workaround involving physically supporting the connectors can expand this. They are held in place by screws, either UTS or metric M3.5A, 0.6 threads. Early versions of the standard suggested that metric screws should be blackened to avoid confusion with the incompatible UTS threads. However, by the 1987 revision this was no longer considered necessary because of the prevalence of metric threads. The IEC 60625 standard prescribes the use of 25-pin D-subminiature connectors. This connector did not gain significant market acceptance against the established 24-pin connector. Capabilities: more information, see Tektronix. Use as a computer interface. HP's designers did not specifically plan for IEEE-488 to be a peripheral interface for general-purpose computers. The focus was on instrumentation. But when HP's early microcomputers needed an interface for peripherals, HPIB was readily available and easily adapted to the purpose. HP computer products which used HPIB included the HP Series 80, HP 9800 series, the HP 2100 series, and the HP 3000 series. Some of HP's advanced pocket calculators of the 1980s, such as the HP 41 and HP 71B series, also had IEEE-488 capabilities, via an optional HPIB interface module. Other manufacturers adopted GPIB for their computers as well, such as with the Tektronix 405X line. The Commodore PET range of personal computers connected their peripherals using the IEEE-488 bus, but with a non-standard card edge connector. Commodore's following 8-bit machines utilized a serial bus whose protocol was based on IEEE-488. Commodore marketed an IEEE-488 cartridge for the VIC-20 but never produced a cartridge for the Commodore 64. Several third-party suppliers of Commodore 64 peripherals made a cartridge for the C64 that provided an IEEE-488-derived interface on a card edge connector similar to that of the PET series. Eventually, faster, more complete standards such as SCSI superseded IEEE-488 for peripheral access. Comparison with other interface standards: electrically, IEEE-488 used a hardware interface that could be implemented with some discrete logic or with a microcontroller. The hardware interface enabled devices made by different manufacturers to communicate with a single host. Since each device generated the asynchronous handshaking signals required by the bus protocol, slow and fast devices could be mixed on one bus. The data transfer is relatively slow, so transmission line issues such as impedance matching and line termination are ignored. There was no requirement for galvanic isolation between the bus and devices, which created the possibility of ground loops causing extra noise and loss of data. Physically, the IEEE-488 connectors and cabling were rugged and held in place by screws. While physically large and sturdy connectors were an advantage in industrial or laboratory setups, the size and cost of the connectors was a liability in applications such as personal computers. Although the electrical and physical interfaces were well defined, there was not an initial standard command set. Devices from different manufacturers might use different commands for the same function. Some aspects of the command protocol standards were not standardized until standard commands for programmable instruments in 1990. Implementation options can complicate interoperability in pre-IEEE 488.2 devices. More recent standards such as USB, FireWire, and Ethernet take advantage of declining costs of interface electronics to implement more complex standards providing higher bandwidth. The multi-conductor connectors and shielded cable were inherently more costly than the connectors and cabling that could be used. Serial data transfer standards such as RS-232, RS-485, USB, FireWire or Ethernet. Very few mass-market personal computers or peripherals implemented IEEE 488. See also, Standard Commands for Programmable Instruments, PCI Extensions for Instrumentation, LAN Extensions for Instrumentation, Virtual Instrument Software Architecture, HP Series 80, Rocky Mountain Basic. References. External links, IEC 60488-1, Higher Performance Protocol for the Standard Digital Interface for Programmable Instrumentation. Part 1, General. International Electrotechnical Commission July 15, 2004. IEC 60488-2, Standard Digital Interface for Programmable Instrumentation. Part 2, Codes, Formats, Protocols and Common Commands. International Electrotechnical Commission May 7, 2004. GPIB/IEEE 488 multiple page tutorial.